Good evening, everyone. My name is Sridhar, and I am from CSC department. And for the AAD Tech Talks on the subject operating system, my topic is about Code for Peace implementation and performance of a parallel operating system. Introduction to parallel operating system. Parallel operating systems enable multiple processors to execute tasks simultaneously, improving overall performance. Code for Peace. Here, the our Code for Peace is a implementation and performance of parallel operating system. What explores these concepts in detail. And the goal of this presentation is to analyze the design and implementation and the efficiency of such systems. Here we can see that we are just in this tech talk, we are going to explain about the parallel operating systems which can enable multiple processes and execute tasks very simultaneously. So we are here to do this uh, topic and explanation of performance of a parallel operating system. Overview of operating systems. Here, operating systems manage hardware resources and provide services for application software. They are essential for controlling process execution, memory management, and device handling. Parallel OS operating systems extend these functions to leverage multiple processors for enhanced throughput. Here, operating systems manage hardware software resources and along with provide some services to the application software. They are very essential for controlling process and execution. So they are also very important for memory management and device handling. What is Code for Peace operating system? Code for Peace is a parallel operating system designed to optimize resource sharing among multiple processors. It aims to reduce contention and improve system responsiveness in high demand environments. Here, the system emphasizes fairness, scalability, and robustness in its implementation. So, as we know about this thing, the Code for Peace is a parallel run operating system which is optimized resource sharing among the multiple users. And also, it aims to reduce the retention, contention, and also gives an high demand environments, and also it emphasizes the fairness and scalability. So, and also robust in implementation. Architecture of Code for Peace. The operating system employs a master-slave architectural model to coordinate multiple processing units. It incorporates distributed control mechanism to ensure synchronization across cores. The architecture supports both shared and distributed memory models for flexibility. Here we can having the CPUs, which consist of register and cache. Here we can see there are three CPUs. So we are learning about the multiprocessing. So these three CPUs are connected to a single memory. So this operating system Code for Peace is a master-slave architecture model to coordinate the multiple processing unit. As we see here, we are having three processing units. So it incorporates distributed control mechanism and to synchronization across the cores. And the architecture support the both shared and distributed models to the flexibility. Implementation details. Implementation. Uh, the system uses lightweight threads and process scheduling algorithms optimized for parallel execution. It incorporates synchronization primitives like mutases and semaphores to manage concurrent access. The implementation is built on a top of a microkernel design for modularity and ease of maintenance. Here we can see the system uses a lightweight threads and process scheduling algorithms optimized for parallel execution. And also, it implementation is built on the top of the microkernel design, so it's used for modularity and ease for maintenance. Scheduling strategies. Here, Outfofees employs a hybrid scheduling approach combining priority-based and fair scheduling. Here, load balancing algorithms are used to evenly distribute tasks across the processes. The scheduling mechanism ensures minimal idle time and maximizes the processor utilization. You can see the scheduling strategies are very important to balance the load on the algorithms and the processors. So the load balancing algorithms are very useful for the evenly distribution of the task across the processors. Inter-process communication. Here, IPC, interprocess communication, is a efficient IP inter-process communication mechanism are vital for performance in parallel systems. The OS uses message passing and shared memory techniques for communication between the processes. Synchronization during IPC minimizes latency and prevent trace conditions. Performance matrix metrics. Here, key metrics include throughput, latency, scalability, and resource utilization. Performance evaluation involves benchmarking with real-world workloads. These metrics help identify bottleneck and optimize system behavior. Here we can see the key metrics are the throughput, latency, and scalability, and also resource utilizations. And here we can see the benchmarking, which are useful in performance evaluation with the real-world workloads. Experimental results. Here, test shows that O4P significantly improves processing speed compared to traditional operating system. The system demonstrates high scalability with increasing processor counts, and also results indicate reduced response times and the better resource management user load. Here we can see the results are indicating that the reduced response time and also the better resource management under load is essential for the board for fees of a traditional operating system. Challenges in implementation. Ensuring synchronization without introducing deadlocks remain complex. Balancing load efficiently across processor is critical to prevent bottlenecks. Hardware heterogeneity can complicate uniform resource management. Here, there are some challenges for implementation. They are ensuring the synchronization without introducing the deadlocks remains very complex for solving the parallel operating system. And also balancing load efficiently across processor is very critical so that no processor is overloaded or overridden. So this balancing load efficiently is most important across the processors. Hardware heterogeneity can complicate uniform resource management. Advantages of parallel operating system. Here, there are some advantages in parallel operating system. They are enhanced performance throughout concurrent task executions and also better utilization of multi-core and multi-processor architectures, improved responsiveness and fault tolerance capability. Here there are some advantages of parallel operating system. They are enhanced performance. The performance enhancement is seen through the concurrent task executions and better utilization of multi-core and multi-processor architectures. And also, yeah, we can see here the improved responsiveness and fault tolerance capabilities. Limitations and future works. Overhead from synchronization can negate some performance gains. Capability issues may arise with legacy application. Future research aims to optimize algorithms and support heterogeneous systems. Here we can having some limitations in the work for fees and the parallel implementation of a parallel operating system. So here are some limitations there. Overhead for synchronization can negate some process performance gains. And also capability user issues may arise with legacy applications. So there are much issues arises with the capability and also with the legacy applications. And future research aims to optimize algorithms and support heterogeneous systems. And also we are aiming with the future. So the future work. So the future research aims to optimize the algorithms and also support heterogeneous systems. Now let us discuss about the conclusion for the Vote for Peace implementation of operating system in a parallel. So here, Vote for Peace exemplifies the potential of parallel operating system in modern computing. Its implementation demonstrates significant performance improvement in multi-core environments. Continued development is essential to address existing challenges and expand capabilities. Here we can see now there are some uh, conclusions we are getting to a point is its implementation demonstrate a significant performance improvement in multi-core environment. And also this continued development is essential to address existing challenges and expand capabilities. Summary. Let's discuss about the summary of this Wolf of Peace implementation of parallel operating system. Parallel operating systems like Wolf of Peace leverage multiple processor and systems for better efficiency. We are using the multiple processor systems for the better efficiency. So the system architecture scheduling and IPC are pivotal to into its success. Ongoing advancement will further enhance parallel operating system and the parallel processing and system stability. And it's all about the code for peace implementation of parallel operating system. And thank you.